All right, y'all, so today we're going to look at difference of squares. So we need to make sure that we remember what a perfect square is. We talked about this already. I don't remember what day we talked about it, but we did talk about perfect squares. And so we're going to look at difference of squares today. So let's just roll through a couple of squares that you need to know. So just find a blank space somewhere. And we're going to list some perfect squares. Here we go. I'm going to add this. All right, so our very first perfect square would be 1. And why is that? That's because 1 times 1 is 1. All right, well, what is 2 times 2? 2 times 2 is 4. Okay, what is 3 times 3? 3 times 3 is 9. Okay, so we're just going to list some. So 16 would be a perfect square, 25, 36. Okay, and obviously we could go on forever. Okay, but we're also going to be looking at perfect squares of variables. Okay, so let's think about this. What is x times x? X times x is x squared. That means x squared is a perfect square. All right, what is x squared times x squared? X to the 4th. That means x to the 4th is a perfect square. What is x to the 3rd times x to the 3rd? That'd be x to the 6th. Remember, you add exponents whenever you are multiplying. Therefore, those would all be perfect squares with variables. Okay, so you got to keep those in mind when you're doing difference of squares. Now let's talk about what difference means. Remember, difference means subtraction. It has to be a subtraction of squares. They cannot be added. Okay, and there's a shortcut to working these. Now, the other day, the last class, I told y'all we worked a problem together and I said there will be a shortcut for this, but I'm not going to teach it to you yet. Okay, so the other day what we talked about was in this case of x squared minus 9. We talked about that the a was 1, there was no b, so it was 0, and that the c was negative 9. So you can still work these the same way that we worked all the other ones, how we multiply a times c and has to add up to b, but you don't have to, because if they are a difference of squares, there is a trick. Okay, so first I'm going to check, is this a difference? Yep, it's minus, so that means it's a difference. Okay, now I'm going to check each term. Each term needs to be a perfect square. So let's look at x squared. Now we just talked about how was x squared made. X squared was made from doing x times x. So is x squared a perfect square? Yes, that's a perfect square. What about 9? Well, yes, because 3 times 3 is 9. If you have determined that it is a difference and that they are both perfect squares, then you're going to split up your two factors. One is going to be plus and one is going to be minus. It does not matter which one. Now I'm going to look at my first term. So what times itself got me x squared? Well, it was x times x. So I'm going to have x and then I'm going to have x. So each group, each factor is going to start with x. Now I'm going to look at my 9. What times itself gets me 9? Well, it's 3. So x plus 3 and x minus 3. And that's my answer. So notice in our last unit, we would have FOILed that. We would have FOILed x plus 3 times x minus 3. And guess what we would get if we FOILed that? We would get x squared minus 9. So if it is a difference of squares, you can just write your answer. Okay, let's look at number 2. So I'm going to check this. I'm going to make sure it's a difference. So yep, it's minus, it's a difference. Is z squared a perfect square? Yes, because z times z gets me z squared. And is 81 a perfect square? Yes, because 9 times 9 gets me that. So as long as all those things are true, I can split this up into two groups, two factors. One is plus, one is minus. What times itself gets me z squared? Z. And what times itself gets me 81? 9. So I've got z plus 9 and z minus 9, and we're done. Those are our two factors. Okay, let's look at number 3. Okay, so first I'm going to check this. Is it a minus? Yep. Is 16 a square? Yes. Is x squared a square? Yes. And is 9 a square? Yes. Okay, so I can do my difference of squares here, but notice this was a little bit different because we had a number in front of x squared. That's okay, we're going to do this the same way. Okay, so I'm going to break this up into two groups. One is plus, one is minus. Okay, now I want to look at my 16. Is that a perfect square? Yes, we already decided that. What times itself gets me 16? 4. All right, so I'm going to have 4. What times itself gets me x squared? X. And what times itself gets me 9? 3. So I have 4x plus 3 and 4x minus 3. Now something I kind of forgot to mention on these, just because I'm always in the habit of doing it, but remember you have to take out a GCF first. On every factoring problem, you have to take out a GCF. But we haven't had a GCF on these first 3. Okay, and these get really confusing. You really have to consciously tell yourself the first step is the GCF, or on these, you're just going to write your answer and it's going to be wrong. Okay, so on number 4, is there a GCF? Yes. 4 is my GCF. So I need to take a 4 out of both of these things first. This definitely gets forgotten a lot. If I divide a 4 out, that leaves me with 1 minus 4n squared. Okay, but I'm still not done. I still have a squared in there, which means I'm not done factoring. Okay, so now I'm going to look at what's left inside. If it is a binomial, which this is, you always want to check to see if it's a difference of squares. If it is, then you can do your shortcut. All right, so this is a perfect square, because 1 is a perfect square. It is a difference. 4 is a perfect square, and n squared is a perfect square. All right, so 1 is plus and 1 is minus. What times itself gets me 1? Okay, well that's just 1. What times itself gets me 4? 2. And what times itself gets me n squared? N. And don't forget about that 4 that we took out from the beginning. This one's a little bit trickier because there was a GCF. I don't know how many times I need to reiterate that you've got to take your GCF out first. Then if you're left with a binomial, check to see if it is a difference of squares. Most of the time it probably will be. Okay, these are practice problems, but I'm going to do these with you. All right, so I'm going to check, is this a difference of squares? All right, well it is a difference. X squared is a perfect square and 100 is a perfect square. Then I can go ahead and flip these up, and there was no GCF. So 1 is plus and what is minus? What times itself gets me x squared? X. And what times itself gets me 100? 10. And there's my answer. X plus 10 and x minus 10. Notice these do not have equal signs. So we are not trying to find the solutions. Notice this says up here to factor. So I'm good with those answers. All right, number 2. Is there a GCF? Nope, nothing that goes into 49 and 25. All right, so I am now going to see if this is a difference of squares. Okay, well it is a difference. 49 is a square, y squared is a square, and 25 is a square. So I can break this up. 1 is plus, 1 is minus. Okay, what times itself gets me 49? 7. What times itself gets me y squared? Y. And what times itself gets me 25? 5. I have 7y plus the 5 and 7y minus 5. All right, looking at number 3. And again, if I'm going too fast and you need to re-watch one of these, just rewind and re-watch it. Okay, number 3. Is there a GCF? Nope, no GCF. Let's check to see, since this is a binomial, let's see if it's a difference of squares. Yep, we have a minus. C is a perfect square. 9 is a perfect square. D squared is a perfect square. All right, then I can flip this up. 1 is going to be plus. 1 is going to be minus. What times itself gets me c squared? C. What times itself gets me 9? 3. And what times itself gets me d squared? D. So there's my answer. C plus 3d and c minus 3d. Now this next part, I am going to show you a shortcut. This shortcut can get all jumbled in your head. So if you do not understand the shortcut, just do the way you know how to factor. There is nothing wrong with that. I would rather you get it right than try to use the shortcut. But we're going to be looking at what is called perfect square trinomials. Okay, here's what that means. So look in this little box right here. Okay, that means your first term is squared, your last term is squared, and your middle term, this is where it gets a little bit tricky. Look at this box down here in the middle. If your middle term is twice the product of the square roots of the first and the last terms, here's what that means. My square root of my first term would be 4x. My square root of my last term would be 3. If I multiply those, I get 12x. If I double that, it is 24x. So this would be called a perfect square trinomial. Okay? Now normally, if y'all were given this problem, you would see if there's a GCF. If there's not, you would go straight into multiplying a times c. Honestly, if it were me, that is still what I would do. Okay, but we still need to teach you perfect square trinomials. Okay, so again, you look at your first term. If it is a square, you take whatever the square root of that is. You take whatever the square root is of your last term. You multiply those. If you double it, and it is the term in the middle, then it is a perfect square trinomial. Now look at how these would be written. If they are both plus signs, so if you have a squared plus 2ab plus b squared, notice how this is going to break up. Both your terms are going to be the same. Okay, a plus b, which means you could write it as a plus b squared, because there's two of them. So if you look at this example down here, x squared plus 8x plus 16, I notice x squared is a perfect square, 16 is a perfect square. If I multiply the square roots of both of those and double it, I get 8x. Okay, so I get x plus 4 times x plus 4. Again, if you do not understand this right now, please do not waste too much time trying to understand it. Just work these the way you know to work them. Okay, notice what it would look like if there was a minus. Okay, so I have a squared minus 2ab plus b squared. I start with a square, I end with a square, but I'm going to have two negatives here. Okay, but the same thing. Middle term is twice the product of the square roots of the first and last terms. Okay, it's just one of your answers is going to be, or they're both going to be minus. All right, so let's look at these next four. We are just going to determine if these are perfect square trinomials. Okay, and we will factor them if we can. All right, so number one. Okay, now again, if you don't know how to do this, just do a times c adds up to b. Okay, no problem with that. All right, so what would be the square root of, first of all, I need to check to see if my first and last term are perfect squares. 4y squared is a perfect square, and 9 is a perfect square. Okay, so I'm going to check to see if this is a perfect square trinomial. All right, what is the square root of 4y squared? 2y. What is the square root of 9? 3. All right, what is 2y times 3? That is 6y. If I double that, I get 12y. All right, so here is what our perfect square trinomial would be factored. Notice I have 2y and I have 3. That was the square root of both of those. So in this case, since I have both plus signs here, I'm going to have 2y plus 3 and 2y plus 3. If you saw this as an answer choice, it would be 2y plus 3 squared, because there's two of them. Okay, and again, I'm probably not even teaching this the best way possible, but if it were me, I would just do a times c adds up to b if you don't get this. All right, number two. All right, so my first term is a square, my last term is a square. Notice we have a minus here, so keep that in mind. Okay, so my first term, the square root of 9x squared is 3x. The square root of 2 or 4 is 2. All right, now in this case, I'm going to multiply those. So 3x times 2 is 6x. These are both going to end up needing to be negative. Okay, what is negative 3x times negative 2? Oh, that's all right. 3x times 2 is 6x. I need to double that. Well, that is not negative 6x. So no, this is not a perfect square trinomial. Okay, we would then have to factor this. So you still have to know how to do A times C and adds up to B. I'm just not going to do that here. We're just going to decide if these are perfect square trinomials or not. Number 3, okay, 9y squared is a perfect square, 16 is a perfect square. Okay, what is the square root of 9y squared? 3y. What is the square root of 16? 4. Okay, what is 3y times 4? That's 12y. If I double that, what do we get? 24y. So this is a perfect square trinomial, which means I can go ahead and write my answer. These are both plus signs. So I'm going to have 3y plus 4 and 3y plus 4. Or 3y plus 4 squared. Either way. All right, we are going to skip number 4. Okay, this right here are the steps that you would go through to factor. So this could help you. I don't really think we're going to need it, but here's what it says, okay? You always start with a GCF, okay? If there is a GCF, you're going to factor it out. After you factor that out, you're going to look at how many terms you have. If you have 4 terms, how do we factor something with 4 terms? We group. Okay, so maybe write that in. You would group. If you have 3 terms, what do? You factor that. How do you factor that? You do A times C, and it needs to add up to B. That might help to write that down. And then, what do? You group. If, after you factor out a GCF, there are 2 terms, you are going to check to see if it is a difference of squares. If it is, you're going to factor that. Remember, 1 is going to be plus, 1 is going to be minus. If it is not a difference of squares, then you are done. Because remember, we already took a GCF out. So let me just give you an example for if you would be done. Let's say you have x squared plus 9. There's no way to factor that. It's not a difference of squares, which means you would be done. Now on the flip side of all of this, if you start with a GCF and there is no GCF, you go straight to how many terms there are. Okay, 4 terms you group, 3 terms, A times C adds up to B, 2 terms, check to see if it's a difference of squares. Y'all are already used to doing this. We're just adding the difference of squares part in today. Okay, so this really should be pretty simple for you. All right, now we're going to do these problems together just for some practice. All right, so remember our first step is GCF. Is there a GCF? No. Then I'm going to see how many terms there are. I have 3 terms. Okay, I'm going to do A times C. So I need 2 factors that multiply to be -1 and add to be 3. Okay, is there anything that multiplies to be -1 and adds to be 3? Nope. Okay, I'm just going to say that this is prime. We will probably not give you one like that, so don't worry about that. You should always, most of the time, have factors that work. Okay, let's look at B. First, we're going to see if there's a GCF, and there is here. There's a 3 and an R. So I need to take the 3R out. If I divide that out, that leaves me with R squared minus 7R plus 10. Now remember what that chart said. It said to take out a GCF and look at how many terms there are. We have 3 terms left. That means I'm just going to factor this normal. A times C adds up to B. The good news is we have a 1 in front, so we can do the shortcut. So I need two factors that multiply to be 10 and add to be -7. This tells me right now it's going to be two negative numbers. Okay, I'm going to go ahead and tell y'all the two numbers are -5 and 2. Alright, so now I can just write my factors since I can do the shortcut. So since it's a -5, it's r minus 5. It's a -2, so it's r minus 2. And then don't forget about that 3r that we took out at the beginning. Okay, so if we look at C, first we're going to look for a GCF, and there is no GCF. Okay, so now we see how many terms there are. There's two terms. So we check to see if it is a difference of squares. Okay, well it is a difference. 9 is a perfect square. D to the 4th is a perfect square. 4 is a perfect square. And D squared is a perfect square. So this is a difference of squares. So I can just go ahead and write my answer. 1's going to be plus. 1 is going to be minus. Now I'm going to look at my 9. What times itself gets me 9? 3. What times itself gets me d to the 4th? Now this is a little bit different. What is the square root of d to the 4th? D squared. And then, okay, so 3d squared plus, and then it would be 2. That's the square root of 4, and what's the square root of d squared? D. And we're done with that one. All right, now we're just going to do a couple more practice problems, and this is really just to get y'all better at this. Okay, I know you're sick of seeing these problems. This is what this whole test is over in, is factoring. And there's different types of factoring, so we just want to make sure we know how to do them all. Okay, so number 1, -2x cubed plus 6x squared plus 108x. Okay, remember our first step is GCF. Okay, we also remember this first term needs to be positive. So if there is a GCF, or even if there wasn't here, we need to take out a -1. Okay, but they do all have a -2 in common. Okay, what else do they all have? They all have an x. Okay, so I'm going to take out a -2x. If I divide that out, that leaves me with x squared minus 3x minus 54. Okay, the great news is here that now look what we're left with. We're going to be able to do the shortcut here because we just have a 1 in front now. Okay, so now I have a trinomial, so I'm going to multiply a times c. I need two factors that multiply to be -54 and add to be -30. Okay, kind of think about what they are. I'm going to go ahead and tell you that they are -9 and 6. Okay, so I can go ahead and write down my answers as x minus 9, x plus 6, and don't forget about that -2x that we brought out from the very beginning. Remember, we do not have to set these equal to 0. We're not looking for solutions. We're just looking for factors. And there is no equal sign anyways. All right, number 2. Okay, first I'm going to see if there is a GCF. Don't go straight to difference of squares, because this actually wouldn't be a difference of squares right now. So see if there is a GCF, and there is. Okay, 3 goes into both of these, and they both have at least y squared. So I'm going to take 3y squared out. That leaves me with 4y squared minus 25. Okay, now we're not done because I still have a squared in here, so I have to see if this can be factored. But now we are left with two terms, which means I need to check to see if this is a difference of squares. Okay, well 4 is a square, y squared is a square, it is a difference, and 25 is a square. So this is a difference of squares. So 1 is going to be plus, 1 is going to be minus. What times itself gets me 4? 2. What times itself gets me y squared? Y. What times itself gets me 25? 5. And then don't forget about that 3y squared that we took out from the very beginning. Okay, so technically we do have 3 different factors here. All right, last one. Now notice I have 4 terms here. I still need to check to see if I have a GCF, and I don't. Okay, so 4 terms, I go straight into grouping. It's the only way to factor a 4-termer. Okay, so let's look at the first group. What do they have in common? They both have x squared. So I'm going to take x squared out, and that leaves me with x plus 2. Bring the minus sign down. This second group, I can factor out a 9, but notice this is a negative 9 that I am taking out. So that leaves me with x plus 2. Now I know you're thinking, ooh, we are almost done. Unfortunately, we are not. So watch this. Now I have x plus 2. And then what else are we left with? X squared minus 9. Now here's where it gets a little tricky, because I still have this squared. So there is a chance that this could still be factorable. I don't even know if that's a word, but it could be factored. Okay, now the x plus 2, I'm done with that. Okay, there's no more squareds there. X squared minus 9 you need to look at. So this is a binomial, so we need to check, is it a difference of squares? And it is. X squared is a perfect square. I have a minus, and 9 is a perfect square. So this is going to factor into x plus 3 and x minus 3. And don't forget about that x plus 2 that we also have. So this is our final answer here. If you didn't quite understand that, rewind and watch that again. Those are rare, but I do think you might have one of those on your next test.